Hello students, welcome to Lotus High School. This is SR from Lotus High School. Here we study a chapter in science subject. The name of the chapter is Structure of the Atom, and in that structure of the atom, now I was explaining the part 4 topics. So see here part 4 topics. In this topic, inert gases or noble gases. Inert gases are nothing but the atom which contains the 8 electrons in the outermost orbit. The 8 electrons in the outermost orbit. And here the inert gases are helium, neon, argon, krypton, xenon. Helium, neon, argon, krypton, xenon. Helium contains 2 electrons in the outermost orbit. The neon contains 8 electrons in the outermost orbit. Argon contains 8 electrons in the outermost orbit. Krypton contains 8 electrons in the outermost orbit. Xenon also contains 8 electrons in the outermost orbit. Okay, except helium, remaining all that inert gases are completely contains 8 electrons in the outermost orbit. Okay, and here what are the properties belongs to that neon, argon, krypton, xenon? All the properties are belongs to that helium. Only that one is different, that is it contains 2 electrons in the outermost orbit. And here that noble gases are otherwise called as a stable gases. What are that here? Stable gases. So see here. Here, so see here, hydrogen atomic number 1, helium. Okay, before going to this topic, once you see here, every time in the 8th class you are writing that Na plus 1, Mg plus 2, Cl minus 1, O minus 2 and A plus 3, and you are getting that doubt how this sodium is getting that plus 1 here, how that magnesium is getting that charge value plus 2, and how that chlorine is getting that minus 1, how oxygen is getting that minus 2, how that aluminum is getting that plus 3. Okay, now I will tell how and why here sodium is getting that plus 1 charge, how that magnesium is getting that plus 2 charge. Now I will explain. So see here, before going to that topic, you must have to write that elements atomic number in that order. Hydrogen atomic number 1, helium atomic number 2, lithium atomic number is 3, beryllium atomic number 4, boron atomic number is 5, carbon atomic number 6, nitrogen atomic number 7, oxygen atomic number 8, fluorine atomic number 9, neon atomic number 10, sodium atomic number 11, magnesium atomic number 12, aluminum atomic number 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18, potassium 19, calcium 20. So here in these elements, helium is the inert gas. Next, neon is the inert gas, argon is the inert gas. Okay, here helium is a stable noble gas and inert, neon stable noble gas and inert, argon noble gas stable and inert. Remaining hydrogen, lithium, beryllium, boron, nitrogen, oxygen, fluorine, carbon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, potassium, calcium. All these are completely unstable atom. What is that nature? An unstable atom. So due to that nature of unstable nature, they want to convert into stable atom. So for converting into stable atom, they are ready to lose electrons and ready to gain electrons. On that time, they are acquiring that electronic configuration of noble gases. They are acquiring that electronic configuration of noble gases. They are acquiring the electronic configuration of nearest noble gas. So see here, first helium. Helium atomic number is 1s2. Okay, orbital diagram 1s2. Neon atomic number 10, 1s2, 2s2, 2p6. That outermost orbit, second orbit, in that one 2 plus 6, total 8 electrons are present. Argon atomic number 18, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. And that outermost orbit is the third orbit, in that one 2 plus 6, 8 electrons. So totally 8 electrons are present in the outermost orbit. So this helium, neon, argon are stable, inert and noble gas. Now see here, first here hydrogen atomic number is 1, electronic configuration is 1s1, orbital diagram 1s1. So here this is unstable. What is that? Unstable. So for converting into a stable, this hydrogen is completely acquiring that electronic configuration of helium. So if it wants that two electrons means completely it gains one electron. After gaining of one electron, hydrogen is acquiring the electronic configuration of helium and converted into a stable atom. So before gaining that electron, hydrogen atomic number is 1. That means it contains one electron, so minus 1. It contains one proton, so plus 1, so total 0. So here this 0 indicates hydrogen is a neutral atom. So all the neutral atoms are completely unstable. What is that? Unstable. Now for getting stability, hydrogen is gains one electron. When it gains one electron, on that time hydrogen contains two electrons. How many electrons? Two electrons. So 2 minus 2. But here there is no change in its protons. So here hydrogen is not loses protons and it not gains protons. So it contains one proton only. So plus 1. So minus 2 plus 1 total minus 1. So here hydrogen is written as a H minus 1. Now this H minus 1 is completely stable and it is completely inert. And the valency of hydrogen is 1. That means how many electrons it loses? How many electrons it gains? One electron. So that one is completely known as a valency, not valency electrons. Valency electrons are different from that valency. Valency electrons are nothing but the electrons which are present in the outermost orbit are known as valency electron. But here we are not discussing about that valency electrons. Here we are discussing that electrons are lost by an atom or gained by an atom. How many electrons it loses or how many electrons it gets, that particular number of electrons is completely known as valency of a particular element. See, lithium atomic number is 3. Electronic configuration 1s to 2s1. And near of this lithium, that inert gas is hydrogen. What is that? Hydrogen. Sorry, helium. Near of this lithium, that inert gas is helium. So this lithium is always acquiring the electronic configuration of helium. So see here, for acquiring that electronic configuration of helium, the lithium is loses one electron. How many electrons? It is ready to lose one electrons, and after losing one electron, it is acquiring the electronic configuration helium. So before losing one electron, the lithium contains 3 electrons, so we are written minus 3, and it contains 3 protons, we are written plus 3. Now total 0. Now this 0 is completely known as what here? This 0 is completely indicates neutral. So total the lithium atom is a neutral atom and this is unstable. So for getting stability, this lithium is loses one electron. When it loses one electron, it is acquiring that electronic configuration of helium. What is that? Helium. So see, after losing of one electron, the lithium contains 2 electrons. So here minus 2. But there is no change in its proton, plus 3. So minus 2 plus 3 completely indicates plus 1. Now this 1 is called as the valency of a lithium. Valency of a lithium. And that lithium is completely written as a Li plus 1. Now this Li plus 1 is completely stable. What is that? Stable. And the valency of lithium is 1. What is that? 1. So here lithium is loses one electron. So that lose one electron is called as the valency of an lithium. Next, here the original the definition of valency is the combining capacity of an element is known as valency. The combining capacity of an element is known as valency. That is the definition of valency. Now see, take another example. Boron. Boron atomic number 5. Electronic configuration 1s2, 2s2, 2p1. And this is orbital diagram. And in that outermost orbit 2 plus 1, 3 electrons are present. And it is completely unstable. So see here atomic number is 5. 5. So 5 electrons are present. So minus 5. 5 protons are present. So plus 5. Total 0. So this 0 is nothing but what a neutral. So if you are observed that boron is a neutral atom and it is completely unstable atom. So for converting into a stable, this boron is acquiring that electronic configuration of helium. Once you see position 1, 2, 3, 4. At the fourth position, helium atom is present. And here 1, 2, 3, 4, 5, 6. At sixth position, neon is present. So here, near of this boron, helium noble inert gas is present. And here near of this boron, okay, here this neon is not present. So that's why here this boron is always acquiring the electronic configuration of helium. So see here, before losing the electrons, that boron contains 5 electrons, so minus 5, it contains 5 protons, so plus 5. So total 0. This 0 is completely known as neutral. So neutral, that means here boron is a neutral atom and this neutral atom is completely unstable. Now this one want to convert into stable. So for converting stable, this boron is completely loses 3 electrons. So after losing 3 electrons, in that boron 2 electrons are present, so minus 2. And there is no change in its protons, so plus 5. So minus 2 plus 5, total plus 3. So now the boron is written as a B plus 3. Now this B plus 3 is completely stable and the valency of boron is 3. What is that? 3. The valency of boron is 3. Okay. Now see here another example. Carbon. So that neutral atom is completely unstable. What is that? The neutral atom is completely unstable. Now this carbon is ready to convert into stable. So for converting into stable, it is acquiring that electronic configuration of nearest inert gas. That nearest inert gas is, see, first here carbon, carbon 1, 2, 3, 4, 5. So near of that carbon, one inert gas, that is helium, and its position is 5. 1, 2, 3, 4, 5. And near of that carbon, one more inert gas is present. That inert gas is neon, and the position is also 5. So 5, 5. So here, if the carbon want electronic configuration of helium is, it loses electron and it is getting that electronic configuration of 1s2. And for gaining electrons, this carbon is completely acquiring the electronic configuration of neon and convert into a stable atom. So that's why the carbon has a capacity to lose electrons and it is a capacity to gain electrons. It can lose electrons as well as in the same case it gains electrons. So see here. So first, near of that carbon, that inert gas is helium. So helium, it wants means it loses how many electrons? 4 electrons. So after losing of 4 electrons in that carbon, only 2 electrons are present. How many electrons? 2 electrons. So minus 2. It loses 4 electrons. 6 minus 4, 2. And protons will be same. There is no change in its protons. So 6 protons. So write it plus 6. So total how much here? Plus 4. Now this C plus 4 is completely called as a stable atom. Stable atom, and the valence is 4. The valence is 4. Okay. Now see here, in that same case, okay, 6, this is one topic. Here, if it wants, here 6 is there. If it wants 10, means it is completely gains 4 electrons or not? It gains completely 4 electrons. So after gaining of 4 electrons, in that carbon, total 6 plus 4. 6 plus 4 means total 10 electrons are present. Total 10 electrons. But there is no change in its protons. Protons will be 6. 10 electrons means minus 10. And 6 protons means plus 6. So charge is how much here? Minus 4. So C minus 4 is also a stable atom. And the valence is completely 4. The valence is completely 4. Okay. I will tell one more example. So see here, carbon atomic number is 6, electronic configuration 1s to 2s to 2p2. Okay, and it contains 6 electrons, so minus 6, 6 protons plus 6, so minus 6 plus 6 total 0. 0 indicates neutral, that all the neutral atoms are completely unstable. They want to convert into stable. So for converting into stable, some atom loses electrons, some atom will gains electrons. So here carbon can lose electrons and it can gain 4 electrons also, because near of the carbon 2 inert gases are present. One is helium and the second one is argon. So for near of that helium it loses 4 electrons. When it loses 4 electrons, on that time in that carbon only 2 electrons are present, so minus 2. Protons will be same, there is no change in its protons, 6 protons, so plus 6. So minus 2 plus 6 plus 4. So here carbon is as C plus 4. So now this C plus 4 is completely stable and this 4 is called the valency. Next, carbon. Near of that carbon, that inert gas is completely neon. So if it want 10 means 6 plus 4, that means we have to add 4 electrons. So after gaining of 4 electrons in that carbon atom, total 10 electrons are present, so minus 10, and protons are 6 protons, so plus 6. So minus 10 plus 6 total minus 4. So here we have to write C minus 4, and this 4 is called as what is valency. What is that valency? So carbon valency is 4. So here according to the definition, for getting stability, how many electrons are gained by an atom or are lost by an atom is completely known as valency. So by using this process we can find that valency. So today's topic is valency. Assignment. Assignment. So here assignment is about in some textbook VALENC is given. That one is also correct. VALENC by ORR VALENC. VALENC by ORR VALENC. Both are correct. So assignment is write the valencies for a particular atom. First one is beryllium. Beryllium atomic number 4. Next, second one, nitrogen. Find the valency of a nitrogen atom. Find the valency of a sodium atom. Find the valency of a chlorine atom. Find the valency of a calcium atom. Okay, find the valency of calcium. So see here, 4 atomic number, 7 atomic number, 11 atomic number, 17 atomic number, 20 atomic number. Here near of that calcium, that inert gas is argon. Near of that calcium, the inert gas is argon. Near of that chlorine, that inert gas is argon. See problem. And the 6th one, magnesium atomic number 12, 7. Fluorine atomic number 9, silicon atomic number 14. How carbon is forming that, that means how carbon is losing electrons and gaining electrons, like the silicon is also gaining electrons and losing electrons. This is different. 9th one, potassium atomic number 19. 10th one, sulfur atomic number 16. Potassium atomic number 19, sulfur atomic number 16. So this is the assignment for you, and find the valency for these elements. So thank you to all. Have a nice day. Enjoy the day. Thank you.